LC oscillations, a qualitative study. Assume that initially the capacitor C of the LC circuit carries a charge Q and the current I in the inductor is 0. This is shown in figure A. Thus capacitor is stored with maximum electrical energy and energy with the inductor is 0. When capacitor is connected in parallel to the inductor, then the capacitor begins to discharge through the inductor in the clockwise direction. As the charge on the capacitor decreases, UE decreases, but energy with the inductor increases in its magnetic field. This is transferred from the capacitor to the inductor. It is shown in the figure B. Figure C depicts the stage when the whole of the charge in the capacitor disappears. The entire energy of the capacitor is transferred to the magnetic field of the inductor. Now, current in the inductor is maximum. The current in the inductor develops an electric field in the capacitor which is directed from bottom to the top plate. Inductor back to the capacitor and electric field is again built up in the capacitor. Figure E depicts the complete transfer of energy back to the capacitor. This is a situation like the situation of figure A, but the capacitor is charged oppositely. Once capacitor is charged fully, then it begins to discharge again. The current will now flow in anticlockwise and shown in the figure F. The process will again continue and finally the stage A comes. The process of charging and discharging continue at a definite frequency. The energy shuttled back and forth between the electric field in the capacitor and magnetic field in the inductor. If there are no resistive elements, then LC oscillators are sustained as shown in following figure 1. But there is no ideal element. Some resistance is present, due to which some of the energy will dissipate in the form of heat energy. So the LC oscillators will become damped oscillations. It is shown in the figure 2. If the energy what is lost in every cycle is fed back to the LC oscillations, then the LC oscillations become sustained as in figure 1. This knowledge is used in the oscillator circuits. Analogies between mechanical and electrical quantities.